Hello all and welcome to chapter 4. So chapter 4 is going to be a lot of exponential and then logarithms. So if you remember from previous years, those two tie nicely together. And we're going to start, as we usually do, talking about graphs, and we'll start with our exponential graphs. So get yourself ready to take notes on the first lesson from chapter 4. So an exponential function is a function like this where the variable is the exponent. So it's always going to take the form of f of x or y is equal to a constant times a to the x. Again, we've got our x as the exponent, and then we call this the base, so base a. Now, let's do a little review of some of the trickier exponents. So here we have an example in number 1 of an exponential function where the constant is 1, the base is 8. So if I ask for something like f of 2/3, that would be the same as 8 to the 2/3. Now I just want to do a little review. When you have a fraction exponent, it's better, I think, to write it as the fraction exponent separately and then the numerator here. So 2/3 is the same as 1/3 times 2. And the reason I like to do this is that if you remember, anything to the 1/3 is a cube root, to the 1/2 is a square root, to the 1/5 would be a fifth root. So this is the same as the cube root of 8. And all of these ones you will hopefully be able to do by hand and say 2, otherwise you can put them into your calculator, but there are going to be ones where I expect you to show the work by hand. So if 8 to the 1/3 is then 2, then this becomes 2 squared, so f of 2/3 is 4. Now, as I said in the objective, part of the things that I want you to be able to do with exponential functions is graph them. And with exponential functions, you are probably used to seeing something like this. This is what we call exponential growth because it's getting bigger over time. And this is the idea where a is greater than 1. So that means that the base is getting bigger. Now, you also might have exponential decay. So think about like radioactive decay from your science class. This is when a is in between 0 and 1, meaning that it is a fraction, so it's getting smaller and smaller over time. Now, this is without transformations, of course. You know, the same things apply, translations, reflections, anything like that. So if I'm asking you to graph, here we have f of x, which is 8 to the x. What I always recommend that you start with is finding your y-intercept. So if you want to find your y-intercept, remember that's f of 0 because it's where x is equal to 0. This is 8 to the 0. Anything to the 0 power is 1. So we know that it will go through the point 0, 1. So if I'm drawing that, one thing I will do is right here. And in order to know which of these and exactly which one's going up, so in this case, right, we have a is 8, so it's greater than 1, so it's going to be going up like this. To tell how steep it is, one nice thing is just to find another point, and that's going to be 8 to the first, which is 8. So it's going to be going up pretty steeply, right like this, like so. Now, one thing you'll hopefully notice as I was drawing this is that there is a horizontal asymptote, just like a rational function, and all exponential functions have this horizontal asymptote right here. And this one, it's at 0, but it could be a translation up or down, things like that. One other question I might ask you is find the function of the form y equals c times a to the x of this graph that we have here. So it's nice that we have 2 points because we have 2 variables, and that's what we're going to use to find each of these. So if I have the point -1, 4, hopefully you would remember this means that f of negative 1 is equal to 4, and 1, 1 means f of 1 is equal to 1. So I'm going to use those facts in this general form that we're given, and I am going to say, well, if f of negative 1 is equal to 4, the y value is 4, c a to the negative 1. So all I've done is take my y value, which is 4, and my x value, which is negative 1, and plugged it in from this point. I'm going to do the same thing from here and say that that's then 1 is equal to c times a to the first, like so. Now, one thing that, if you remember with systems of equations, we'd usually like subtract them to cancel out. Since these are multiplied terms, we're not going to subtract, but if we divide on both sides, that's still equal. So then this becomes 4 over 1, which is 4, is equal to c's cancel out, a to the negative first over a to the first. Now I'm going to simplify that with the exponent rule, and that tells me that 4 is equal to 1 over a squared, because I'm dropping the negative exponent down. I'm going to multiply both sides by a squared and divide by 4. So then a squared is equal to 1 over 4. And therefore a, we could say, is equal to plus or minus 1/2. But if you remember here, we have a decay model, which means that a is in between 0 and 1. So then a must be equal to positive 1/2. Now that we know what a is equal to, we can solve for c. So since we know that 1 is equal to c times a to the first, or just a, we can say that that's 1/2. So then 2 is equal to c, meaning our final answer, y is equal to 2 to the 1/2 x. There are ways you could slightly simplify this or write it differently, but that's a perfectly good final answer. Please let me know if you have any questions about exponential functions, and nominate any questions you have from the homework in the form attached. Talk to you later.